So what did you guys get? Dylan, what did you say? Want to explain it to us? How you got there, Dylan?
I kind of just guessed.
How come? Okay. Good idea. So, let's just talk strategy for these. What's your strategy?
Well, I look for the slope at 0 or 1, 0. Or I guess, no, because that's a vertical. No, that's a horizontal thing. So I guess I should have looked for it at 1, 1. I think that would have helped me. Because I got x minus 1. So I got dy dx at x equals 1 is 0.
Okay.
For the slope. I don't know. I was looking for the slope of it. And then trying to create that equation of the tangent line, I guess.
Okay. Well, a good place to start is certainly any of those, like all these horizontal. So the slope is 0, which
Right.
is true here as well. And then, like, you can start eliminating some. Like if we pick -1, 0, and just start plugging it in and seeing, we know the slope there is 0. So we have to make sure that all, whichever answer it's going to be has to give a slope of 0. So we'll start with A just to see if it's a candidate. So if I plug in -1 times 0 minus 0, that works. So far, A works. B, -1 times 0 plus 0, that still works for this first point. Okay. C, -1 minus 0, that one doesn't work because that gives a negative slope instead of a 0 slope. D, -1 minus 1 is -2 times 0, so that one is still valid. And then -1 minus 1 cubed is not going to work. That's not a 0 slope, so that one doesn't work. Okay, and then maybe pick a different point. Like you said 1, 1. So let's go see if that continues to work. So plug in 1 times, it still should be a 0 slope there. So 1 times 1 minus 1, that still works. 1 times 1 plus 1, that's now 2. So that's out. Okay, now we're down to A or D. So, and then 1 minus 1 is 0, so times whatever. That one is still working at that point, right?
Yeah.
And so, and honestly, if we had picked any other one on that, on x equals 1, these two would still work. Does that make sense?
Yeah.
So what do we do next?
Are you able to estimate?
Sorry, go ahead, bud.
What if you pick 2, 1, or 1, 2? Or, oh wait, no, that's right. Yeah.
Okay, so that kind of tells us that we have to go pick a different point, and just kind of check if it matches what appears to be the slope. So I'm just going to grab like 2, -1 maybe. Okay. Let me change color actually for that. 2, okay, so 2 times -1, and this one we're not looking for a 0 slope, but negative. 2 times -1 is -2, minus -1 is still negative. So, and that looks like a negative slope, so that one still works. Okay, and then on D, 2 minus 1 is 1, times a positive, because once we square -1, that becomes positive. So this one doesn't work for the green circle, that point. And that leaves us with A. that would be my suggestion for how to work through those kind, is start with this horizontal slopes, but then know that it's not necessarily enough to do one. That kind of help?
Yeah.
Alright, do you guys remember these kind? Do you remember how to draw them in?
Yeah.
I don't know. It's like the first practice page of 7.3. So we can just quickly talk through a review of it. We don't have to really do one. Like, let's talk about 4. How would you do it?
I just think every point.
Okay, so you just go through and just plug every dot in. You didn't like the table. Okay, that works. So let's do this top left point just as a review. So -3 for x and +3 for y. So what is that? -2/1. Okay. And then do try, when you sketch them, do try to match the slope. Like imagine connecting that top left dot to one that's 2 down. Something like that. And so yeah, you can just plug in every point and just calculate slowly each one. I think with the table, you start to see some patterns that can save you some time. Do you remember what you like? Do you like the table, or do you like to just look at points and graph each one?
I've never seen the table.
Did you like it?
No, not really.
Okay. Do you remember from Friday? I think table is, I don't know. It's obviously
I feel
pretty
like it's
repetitive.
more organized and you're probably less likely to mess up on it
Yeah.
because you are more organized with it, but I feel like it's more tedious and I just don't like it because of that.
Okay. And it's a lot more writing, and I think it depends probably on what your differential equation is. If, you know, like this one, it's pretty fast to just say -2/2 and not necessarily fill out a table, but this one, it might be nice to have a little bit more organization.
Right.
It just depends. Yeah, anyway, on this, on any -1, we're going to have a 0. So that's fast without doing a table.
But when y equals 2,
Yeah, y equals 2, that's not true, is it?
well, it means it's shit,
Undefined slope,
Undefined.
which means it's vertical.
that is so.
Yeah. So we have one spot, one line where it's vertical. All the y equals 2's are going to have vertical slope. So I think it's good to have both in your toolbox, both, like just doing the point and the table, because that saves some time. For sure. Okay, are we just finishing it? Are you guys working on it? Okay. Yeah. This is a really weird one, isn't it? I don't remember seeing any vertical ones on Friday. You guys remember that?
No.
So that's good. I'm glad we looked at this one. Alright, I'm going to leave mine undone since you guys are good. And that one we're waiting on me. But just actually, so I can put it on here. For 1, 3. What did you get there? 1,
I got
2, up 2, I think.
Up to, yeah.
Okay. And then, let's see, 1, so 1, 1 is negative 1. No, negative 2.
It's essentially just flip the opposite sign of what you have on the top.
Okay, and then negative, oh, that's 0. So 3. It's hard on those side ones because you don't have the other dots. Okay.
That one's, so it's like the only positive one. It flips from like the top row.
Yeah, so essentially,
At
row
y
under-
equals 2 is like a horizontal asymptote.
and it's kind of reflected over y equals 2.
Okay.
And those ones are just steeper than the ones on top.
Yeah.
Thanks. Okay.
Yep.
I think that covers what we did, just to kind of get back into these, since they are so different than what we've done. So today we're going to talk about. Zoom out. There we go. So we're going to estimate solutions based on these with slope fields,
Okay.
which I think is what you were talking about is easy on the test, I think.
Yeah.
Okay. All right, so we know that we have lots of particular solutions represented by a slope field. And so we're trying to find, like in these two cases, the one that goes through a specific point, which makes it a single particular solution. All right, so we have 1 minus xy. We saw this the other day as one of our intro problems. Here's how you do this. So plot the point at 0, 2. And then our particular solution has to go through that point. It's a sketch, it's not going to be perfect. So basically from there, just follow the current. Remember we talked about that on Friday, just follow how the slope would kind of take you. Something like that. So that is the particular solution for the point 0, 2. Kind of like giving you that initial condition to solve for C, essentially. Probably need to drop that down just a little bit lower. There we go. Okay, and then same, let's do it with negative 2, or negative 1, negative 2. Something kind of like that. If that was an AP question, that would be pretty sweet, right? Right.
Well, it was an AP, or it was like 1 point on the FRT. But it's not worth a whole lot.
Yeah. Yeah. All right, next. This next kind is going to reference back to your function families, hopefully that you remember from Algebra 2 and Pre-Calc, the general shape of graphs. I have that parent function poster up there, which if you want, you can take a picture of if you feel like you don't remember them. It doesn't have all of them, but it has most of them. So just for that, like what kind of function is this? It's a rational function, and it has a horizontal asymptote where? It's at 0.
It's a whole at 0.
It has a horizontal asymptote, though. No. Because our denominator has a bigger...
horizontal.
Horizontal.
Okay.
Yeah.
So that would be.
Okay, so you could look for that, potentially, like expect to see that. And yes, we have you're talking about the vertical asymptote.
Yeah.
And whole, we have a vertical asymptote at 2. Okay? So, and he's getting that from factoring this denominator.
Right.
If I saw this question though, I'm looking at the domain that it's given us, and I'm just saying e to the x. Because like, they're not giving us any negative x factors. Oh yeah, they do.
And plus it doesn't mean that they're not gonna exist, right?
Yeah.
It's like a snippet. Also, there isn't a hole here for this one. We have two vertical asymptotes.
Yeah, I think I might have factored the x and x.
Okay. What kind of function, or what does the graph for an e to the look like? Yeah, so some kind of version like that. Okay, and then tangent of x over something is going to be some version of this repeated pattern, right?
Right.
Okay. I think I'll put those out to the side here. Okay, do you remember what rational function graphs typically look like? There's tons of versions, right? Like we can have this kind. We could have like this kind. This kind.
I feel like that's the only one that's really, I mean, I guess tangent has vertical asymptotes, but that's really the only one that has a vertical asymptote.
Okay, and then this one, this is also a rational function, but it has a diagonal or oblique asymptote, right? A slant one.
Right.
Okay. Anyway, so knowing your parent functions kind of can direct you, but that's not the only thing you can do. What else can we do to try to match these? Oh, and another thing to point out. Which of the following could be a solution? You should probably star that, because these aren't, it's different than what we did just a bit ago in our kind of like our warm-up, where we were trying to find the differential that matched the slope field. This is like which one could be the particular solution for that, right? So we have to think integral, kind of. Think one level above what the slope field shows. So what's still a good strategy? Like we can do a similar start to what we did in that problem.
Just take the derivative of each one of those and then plug in a point.
Okay. You could.
That might be really long.
Yeah. But we could just pick a point though, right?
Right, and
Yeah.
it gives us 0, 0.
Yeah. So at 0, 0, that point. A little smaller. Did I get it right on? Yeah. Okay, so what do we know about that initial condition? Well, sketching your graph from that point, so it kind of trails off to the right, and then it kind of comes up onto that vertical asymptote. Okay, we also see some things, like there's stuff going on, like I think you pointed out, there's stuff going on over there too, but so it looks like that. Is that the tangent graph?
No, it kind of looks like the sine.
Okay, so it's not that one.
It's not e to the x.
Yeah, because we would expect that to, it wouldn't have two arms going up the same direction. How do we distinguish between these two?
Well, a would approach 0. Like and
A would approach, oh,
a. Yes.
what do you mean by it would approach 0?
Like the graph would make sense.
Yeah, I think you're right. Also, this has two asymptotes vertically, right?
Yeah.
Like, for sure one at -2, but it would also have one here where we would have that blank space. So it can't be that one. But I do agree, it would approach 0, probably, right? Okay. So how about D? Is it safe to go with D? Have we eliminated enough?
Because you would only have that one vertical asymptote at -2.
Okay.
And then the numerator kind of gives you a
almost a shape of a parabola, so you would know that your arms are gonna go in the same direction, I guess you would say.
Okay. And this is that kind that is tucked between, like this kind that's tucked between a vertical and a diagonal asymptote.
Right.
Okay. Which kind of looks like what we just drew. Cool. So definitely knowing your apparent functions help that. But don't forget to plot the point, sketch in the graphs, and start getting an idea of what it looks like. Alright, so where does dy dx equal -1? We're just looking for a slope of -1. So can you see it, first of all? See where it's probably true?
Yeah. Anywhere like at 0, -1, and then you just follow the path of.
Yeah. So it's kind of, actually I'll highlight this one.
Couldn't you just say like y?
It's kind of those lines that look to be -1. But yeah, so I think you're getting onto it maybe.
X plus 1.
So if we have this differential equation, we're talking about dy dx equaling -1. Can't those just be equal?
Yeah.
Yeah. So let's just set x plus 1 over y equal to -1. Okay, and so that line is what I just highlighted in blue.
Right.
That should be -x minus 1, sorry.
Oh yeah. Do that with like in parentheses.
So this line has all those, it says describe all points that have that slope of -1. Okay. That's easy.
Yeah.
That is a pretty typical FRQ type question. Do you remember if you had anything like that?
I don't know if I don't remember seeing anything like that. I feel like I would have, because I feel like that's really simple.
Yeah.
And I feel like most of this stuff, usually there's only one problem that gives you 1 point on the FRQ, and I feel like that would be worth 1 point.
Yeah.
And because it has to deal with slope fields, I feel like sketching of the slope fields is more common.
Yeah.
Than,
I agree. So I'm guessing you'll probably get some kind of multiple choice, like match the differential with the slope field, but then this kind, one of these types, and probably the drawing. All right, so this is kind of the proof negative, like what is it not, and explain why that's not the slope field for this particular differential. So what do you think? What do we have to do to prove that?
Well, I mean, the slope field is like all the lines on the same line or on the same x are the same, which means that we're changing based on x.
yeah.
But if it was going to be something like y, then all the x, like all the lines on the same x would be the same.
Okay. I agree, and I think that's a good description. It'd probably be good to just pick one, like you could say that, but then say like, for example, and pick an x, particular x value. Like for this one, it, like you said, it depends on y, so that would imply that all the slopes would be the same in the y direction once you pick a single y value, but they're clearly not. So just pick one, right? Like if you did y equals 1, it goes from 0 over to quite negative, and it shouldn't.
Right.
So, yeah, that's all.
I feel like they kind of mess with you with the variables. Like they try to change them on you. You're used to seeing just X and Y.
Yeah.
And I feel like if they give you a Y value that's your, I feel like, I don't know, I just feel like they try.
Yeah, I agree. Plus, they stuck this dy dt in here, too.
Right.
So, Christian, are you going to put punctuation in capital letter?
I'll do my best.
Okay.
No, it's my priority.
It's not?
No.
You don't want to write a perfectly written paper on there?
Right? No.
Does that on your paper look, it looks like 0, doesn't it?
I think it is.
Okay. So something like that would be good enough explanation. I think that's all.
Can we just use like the point like 5, 1 and say like the slope at 5, 1 should be only negative 0.3, but here it's obviously bigger. You know,
Yeah, 5, 1.
5, 1.
Yeah?
Well, I feel like you
I
can do the
think-
same at 0, 1. Because if your Y value is 1, your slope should be 0.3. But at 0, 1, it's
Oh, that's
obviously
probably
0.
a better one.
Because you can clearly see that that one's 0.
Yeah.
Like at 0, 5, it's like it's has to be negative 1.5. 0. Yeah, that's probably a better one.
And anywhere at Y equals 0, your slope should be 0.
That's a good line to use. Because it's clearly not.
Right. Because that one, you can definitely see that your slope is negative rather than where it should be 0.
Yep.
That's 'cause it's the-
I would caution you on like any of these that look 0. I think
Right.
because this is 0.3, it might not be
Really
super
hard.
distinguishable from 0 potentially.
fair.
They could maybe make an argument against you on that, but
Yeah,
but
that's
I do agree with this line being obviously half of them don't even look close to 0,
Right.
and they should be. So. Okay. So either, any of those I think is good. All right. So what do you think? Is stuff going okay for you?
I feel like it's pretty well.
Do you like it?
Yeah, I feel like it's simple.
It's not bad.
It's more or less
I
conceptual
don't enjoy
thinking.
doing it.